Hello? In solving this given triangle, we need to understand what are the given and what are the unknowns. Please be reminded that for a triangle or any triangle, there should be 3 sides and 3 angles. Here, we are to complete the measurements of this given triangle, where we are only given with the measurement of one angle which measures 27 degrees and one side which measures 10. Take note that we could use 2 of the most important theorems involving right triangle, which would focus itself on the sides, that's the Pythagorean theorem, and the angles, which is the triangle angle sum theorem. We can start by solving angle theta. Now theta refers to this angle here, and we are going to use the measurements of the given 2 angles. For this, we know this to be 90-degree angle, and we have here 27 degrees. We can use the concept of the triangle angle sum theorem, where we can solve for the measurement of angle theta by subtracting the given measurements of the 2 angles from 180 degrees. This is per triangle angle sum, which tells us that if we're going to add the measurements of all the angles in this triangle, it would sum up to 180 degrees. Again, we will subtract 90 degrees given by this box and the 27 degrees given by this angle here, which will yield us measurement which is closer to, or it's actually equal to, 63 degrees. This should be the measurement of angle theta. Now, aside from the triangle angle sum theorem, since we are 100% sure that this is 90 degrees, we could just simply use the concept of complementary angles. We're talking about the measurement of this angle theta when paired with 27 degrees. We know that this measurement is already 90, and once we subtract this, it automatically results to 90 degrees. Hence, we can say that the measurement or the sum of the measurement of these 2 angles here, theta and 27 degrees, must be equal to 90, and hence they must be complementary. So if we're going to subtract automatically 27 from 90 by solving its complement, you will still get the same result. Now let's proceed to the sides. Here, we are only given with one side measurement, and the 2 other sides are unknown. We cannot yet use the Pythagorean theorem here in completing the measurements of the sides, nor any of the special right angle theorems before, like 30, 60, 90, and the 45, 45, 90 right triangle theorems, since one or the given measurement of this angle is 27 degrees and it's not a special angle. Here, we can use the concept of the 6 trigonometric ratios, or specifically 3 of the 6 trigonometric ratios: sine, cosine, and tangent. In solving for the measurement of side x, we are going to look into the reference angle, which is 27 degrees, and the given side, which is 10. In terms of this reference angle, 10 is what we know as the opposite side. X is always your hypotenuse, and the remaining side is your adjacent. In determining which trigonometric function to be used, again, we refer to what is given and what is the side that you are solving. So the given side is the opposite side of the 27 degrees, the reference angle. So we use O, and the side that we are trying to solve is the hypotenuse. So we're looking for any of the 3 trigonometric ratio, the sine, cos, or tangent, which will use opposite and hypotenuse. And it's the trigonometric function of of sine. So we can solve it in this manner. Sine, and you give here 27 degrees equal to the ratio of the opposite, which is 10, over x, which is your hypotenuse. Let me increase this side here for further computation. To solve for this, we are going to apply the fundamental law of proportion, where we treat this as over 1, and we could multiply or cross multiply the values, which will give us x times sine 27 degrees equal to 1 times 10 being 10. And with this, we will be dividing both sides by sine, so that what remains on one side could only be the value that we are solving as x. So you have here sine 27 degrees. In short, the value for x is the value for this, which is solved as 10 divided by sine 27 degrees. This is not exact, and we are going to round it off into 2 decimal places. So instead of using equality, let us use the symbol for approximation. So x is approximately equal to, when rounded off into 2 decimal places, you have 22.03, and we place units here since there's no given measurement or unit of measurement. You have 22.03 units. So this is the value of the hypotenuse for this given right triangle. We can use the same concern, same processes in solving for the measurement of angle y. We can use the relationship of the given side, which is O, and that's again with reference to 27 degrees, and then we are going to solve for y, which is your adjacent. So O and A, what you're going to use here in solving for the value of y is simply the trigonometric function tangent of your 27 degrees is equal to the opposite, which is 10, that's TOA, over y. Using the same processes, you can multiply both sides. Let me increase here and here. So you will have cross multiply, that's all over 1, y times tangent 27 degrees is equal to 1 times 10 being 10. And then we divide both sides by the trigonometric function of tangent 27 degrees, so that we could cancel this out just like earlier. You will have here tangent 27 degrees as the denominator of the fraction, where 10 is your numerator. And in solving for the value of y, we simply need to determine the value when we divide 10 by tangent 27 degrees. And since again, this is not exact, we will not be using equality, hence we will be using a symbol for approximation, approximately 19.63, and since it's a side, we use here units. So this is how we solve this right triangle as we complete the unknown measurements, one angle and another 2 side measurements.